Okay, let's do example 1.7. Okay, in this example, you are asked to determine the limit, right, of a recurrence sequence given its initial condition and the recurrence relation. Okay, take note that this question, the important part is the question specified this sequence has a limit. Okay, as we know that not all the sequence has a limit as n goes to infinity, but in this example, you're given that this sequence has a limit and you're asked to determine the exact value of this limit. So we are not supposed to use the GC and observe the table and scroll down all the way to see what happens to the value, because GC will never give you an exact value. So we are expected to work out this limit algebraically. Okay, so how do we do this? Okay, the important concept here is the recurrence relation given in the question will hold, right? No matter what's the value n. So example, right? Example, even if n equal to 10,000, right? This recurrence relation, v once 10,000 equal to 1 over v999 plus 1 will still hold. Okay, why it is important to understand this fact? Because as n go to infinity, n minus 1 will also go to infinity at the same time. So if the subscript go to infinity, that means this sequence, given it converges to L, both Vn minus 1 and the Vn term will tend to L. And these two values should still satisfy the recurrence relation given to us. So we can substitute both Vn minus 1 and Vn with L. And now we are dealing with an equation involving L only, and we are supposed to find the exact value of L. So moving forward is just solving a quadratic equation. So why quadratic? We multiply both sides by the denominator, right? Then we move the term around to make it a standard quadratic, and of course, observe this one cannot be factorized. Okay, we use a formula, so L should be negative 1 plus minus square root 5 over 2. In other words, we have two possible answers. One is negative and the other one is positive. Okay, so does that mean that there are two possible limits? In this case, no, because by right the sequence should only converge to one of them. Right, so how do we tell which answer should we keep? Now we come back to the initial condition as well as the recurrence relation. Okay, realize that if v1 equal to 1, my v2, which is 1 over v1 plus 1, right, the numerator and denominator are both positive, right, so the answer will be a positive value. v3, which is 1 over v2 plus 1, the numerator and denominator are also both positive. That's why if you continue to realize, right, for all the terms in this sequence, right, Vn will be positive for any term. Okay, so if that is the case, that means there's no chance for the limit to be a negative value. Right, so we will reject. Okay, reject this since I must have a positive limit based on this analysis, right? So this is our answer. And take note, right? We should keep the answer in the exact form. In fact, actually, you can check this answer against the GC answer, right, from the previous example. Right, this is called the golden ratio, and this is approximately 0.618. Of course, in this question, please don't use this value, right? But it's quite an important value in mathematics.